Good evening everyone. This is Pavan Kumar. Today I am going to discuss about a preparation strategy for the environmental engineering. I am not going to deal with any type of numericals in this session. For the numericals with an important topic, so that is allocated one more session that will be happening on the day after tomorrow. So today this is a very small session where we will be discussing about what is the weightage of the environmental engineering with respect to the GATE examination, and out of all the topics where they are focusing more, and in the given topic or in the given chapter, so what are the major topics they are covering. So that those are the things that we are going to discuss now. So in the case of this environmental engineering, if you see the GATE pattern, whatever the GATE examination you take from the past papers and all, out of the technical subjects in civil engineering, two major pillars of technical subjects are, one is geotechnical engineering and other one is environmental engineering. Few years back, so 3 or 4 years back, there was quite a difference between the weightage of geotechnical engineering and environmental engineering, where geotech is quite heavy, environmental is quite less compared to that. But now, if we see the past 3 to 4 years, more or less both weightages are going to be same. So first of all, in the case of the environmental engineering, the GATE weightage is now 12 to 14 marks on an average of 13 marks. You see, whatever the recently happened GATE examination in GATE 2023 also. So in GATE 2023, set 1 and set 2. In set 1, 1 mark questions are 3, 2 mark questions are 5. Same in set 2, 3 questions and 5 questions. So overall, in GATE 2023 from set 1 we got 13 marks, and in set 2 we got 13 marks. Not only about the 23, the same pattern was happened in GATE 2022. And in GATE 2021, in set 1 we got 14 marks, and in set 2 13 marks. In GATE 2020, so one paper we got 12 marks and another paper we got 14 marks. So on an average of, the minimum is 12, maximum is 14 with an average of 13 marks from the GATE 2020 onwards. Prior to the GATE 2020, where there was no much exposure towards the air pollution and solid waste management, so number of questions was quite less. The quite less is nothing but, see, instead of 2 marks as a 5 marks, that means 5 questions, only 4 questions used to appear. By then, the weightage of the environmental engineering is 10 to 12 marks. Now, 2 marks has been increased for the environmental engineering. Now, the weightage goes to 12 marks to 14 marks. Whereas for geotechnical engineering, it is 13 to 15 marks. 13 marks to 15 marks for geotech, 12 to 14 marks from the environmental engineering. So, more or less, both subjects has a same weightage. Now, coming to the point, what are the topics that you need to cover? First, let me explore the whole topics as per the GATE syllabus, and through the GATE syllabus, what are the major topics that we need to cover while preparing. Okay, so I hope you know the weightage of this GATE. So let's see what are the various topics that we are going to deal. Basically, whatever the things that are related to the environment, we are going to deal. In environment, as a biosphere, we are going to discuss about 3 things. Hydrosphere, water. Lithosphere, earth. Means whatever the waste that we do and develop and manage on the land surface. And atmosphere, so gases and suspended particulate matters. So these are the 3 things that we are going to discuss. Hydrosphere is nothing but related to the water for drinking purpose, and after utilizing that water, whatever the wastewater that we produce for the disposal purpose. For water distribution and wastewater disposal, we use hydrosphere, which is nothing but water bodies. And whatever the solid waste that we produce from our community, Community means it can be a village, it can be a city, it can be a town, or it can be a group also, or it can be a colony. So whatever the waste apart from the liquid, so and essentially in the form of a solid, that we are going to dump either in the open lands or we are going to collect in our bins. Every alternate day, municipal corporation, GHMC people would be coming, they would be collecting that waste and they will be sending to the processing stations, then disposal. That we do on the lithosphere. And then finally, every day, lots and lots of gaseous pollutants that we are releasing into the atmosphere by means of automobiles and by means of the industries. So these are three topics we have to cover, and those are: number one, water supply engineering. The water portion is divided into two parts: water supply engineering. Second one, wastewater engineering. So in the case of the water supply engineering, we primarily deal with how to supply water to the community. We don't supply water directly to the community. We are going to supply the water by treatment. So we discuss about what are the various treatments that we need to incorporate before supplying the water to the community. And wastewater engineering. Once you distribute or supply water to the community, to us, after utilization of for that, whether it is for the domestic purpose or industrial purpose, cooking purpose, bathing purpose, cleaning purpose, whatever it is, once you utilize that water, it is no more a fresh water, it becomes wastewater, simply known as a sewage. And we should not keep the wastewater in our household or in the community. We should dispose that wastewater immediately out of the community. So for that, how you are going to dispose? You should not dispose the waste directly into the water bodies. Again, you have to treat. That is a wastewater treatment. So you do treat and dispose. In water supply engineering, you treat and distribute. In wastewater engineering, you treat and dispose. So these two depends upon the, it's a cycle from the water bodies to the community, from the community to the water bodies. And then we'll discuss about what is the waste essentially in a form of a solid in our community, solid waste management. Here we don't deal with any treatment, here we deal with the management. So it's not about the treatment, it's about once we collect the entire solid waste. So in our community, there will be a lot of solid waste, especially from our homes. What is the solid waste we produce is nothing but leftover food material, leftover vegetables, or vegetable peeling marks, or any dust that we produce from our house. And you see outside lots and lots of plastic bottles, glass bottles, rubber pieces, metal fragments. Those comes under the solid waste. Here we don't treat, we just manage. We divide them into wanted waste, unwanted waste. Whatever the waste that can be recycled and reused, like paper, plastic bottles, rubber pieces or metals, they will be segregated, they will be processed towards the industries. And whatever the food waste that we generate that cannot be recycled and reused, we are going to dispose far away from the community. So we don't deal with any treatment here, we only deal with the management, right? And fourth one is air pollution. So water is divided into two portions, and second one is solid waste, then air pollution. So what are the different type of the air pollutants that we are releasing into the atmosphere? So first of all, air, atmosphere is a thin layer over the earth's surface. It has some fixed composition of the primary gases like nitrogen, oxygen, argon, carbon dioxide. So majority of the gases is nothing but nitrogen and oxygen. Apart from that, if any artificial gaseous things enters into the atmosphere, they will change the composition of the atmosphere and causes pollution known as air pollution. And last one is noise pollution. But noise pollution this topic has been removed from the GATE syllabus. From the past few years, the last time they asked a GATE question from noise pollution is 2017, if you see the previous GATE questions. But later on, you see the GATE syllabus, even noise pollution is not at all mentioned in the GATE syllabus. This is only for ESE, Engineering Services Engineering Service Examinations. So for that only it is going to be important. So we primarily focus for the GATE over here, water supply engineering, wastewater engineering, solid waste management, and air pollution. So out of these 4 topics, so we deal all forms of treatment and distribution in the water supply, all forms of treatment and disposal in the wastewater engineering. Okay, so now if I represent first water supply engineering. In the water supply engineering, we discuss about lot of chapters, primarily 9 chapters we are going to deal. So first one is population, forecasting, and water demand. Next, number 2 is sources of water and conveyance also. So how you are going to convey. Number 3, quality of water. Number 4, there comes the treatment, which is plain sedimentation. Then we go with coagulation. Then we go with the filtration. Then disinfection. Miscellaneous treatments. Miscellaneous treatments and water distribution system. Okay. So now these are the 9 topics that comes under water supply engineering. First of all, if we want to supply water to the community, just like a Hyderabad, or let's say example of Hyderabad, if a Hyderabad consists of 1 crore of population, to supply water to the 1 crore of population, we should not depend upon or rely upon the present population. Whatever the scheme that we are going to construct, whatever the water supply scheme that we need to construct, that should fetch and that should service for the next 30 to 50 years. That period we call it as a design period. So at present Hyderabad population is 1 crore, but in the future it is not going to be 1 crore, it will be definitely more than that. So we have to forecast that future population by using some of the mathematical and graphical techniques. So that is a population forecasting. And once I know the population forecasting, then how much amount of water a person is needed on an average, that we call it as a per capita demand. So that is completely based upon the IS code 1172/1993. So based on that code and CPHEEO manual, so we are going to decide how much amount of water is required for person for various activities. That we deal in the chapter number 1. And in chapter number 2, once you know the future forecast population, once you know the demand of the Hyderabad community, once I know that much amount of water that required per Hyderabad. So let's say in a Hyderabad per a given day, I require 100 mld of water. So I want to supply water to the Hyderabad community. So I have to supply 100 mld. 100 mld means 100 million liters per day. But in order to supply that, first of all, that much amount of water should be present in the source, right? So we are not going to prepare the water artificially. We take the water from certain sources. And what are the sources that we have is nothing but surface source and subsurface source. The prime source of water is nothing but surface source. Surface source, the quantity is very high, quality is quite less. Subsurface, groundwater, quantity is less, quality is high. So here I have to give focus first for the quantity. Once I have a huge amount of quantity, then I will fix later how to treat to improve the quality. That we deal in the second chapter. And there comes the most important topic in the water supply engineering. This is quality of water. So once I know the population, once I know the water demand, once we know the source, now we have to fix out of the n number of sources, which source is suitable for the distribution. And if that source is there, what are the various type of impurities in that source to be treated? We should not supply the raw water. Raw water means direct water from the river to the community. We treat it. In order to treat, first of all, you need to know various characteristics of water. Some of the characteristics like physical characteristics, like turbidity, suspended solids, color, odor, taste, temperature. And some of the chemical characteristics like hardness, pH, alkalinity, chlorides, sulfates, dissolved oxygen, nitrogen compounds, fluorides, and metals. And biological parameters like how much amount of bacteria, disease-causing bacteria known as pathogens, are present in the water by doing various techniques like a membrane filter technique, most probable number, MPN method, coliform index test. So this is very important chapter in the water supply engineering. Every year you can expect a minimum of 2 to 3 marks. In GATE 2021, there was a time they asked 5 marks from this chapter number 3. 2 marks question and 1 mark question. And a minimum case you can expect 2 marks from this chapter. Do not skip this chapter. That does not require the prerequisites and does not require the post chapters also. It is completely for the chapter number 3, quality of water. Okay. So if you want to get very good marks from the water supply engineering, don't skip the topic quality of water. Very simple and very easy topic. Okay. First let me give this one, and in the quality of water, what are the different type of questions that one can expect, that we see later. So in the quality of water, so 2 to 3 marks. And then we go for the treatment. So first of all, we remove the suspended particles by means of plain sedimentation, and the size next to that, colloidal particles, by imparting some coagulants, we go for coagulation. And once we remove that, if any particles left over, to remove any particles left over in these 2 methods, and dissolved minerals and certain amount of bacteria, we go for filtration. And finally, once all forms of treatments are done, before disposing to the community, you throw some chlorine on the water. That is nothing but chlorination, which is to kill the germs. That is by means of disinfection. So chapter number 4, 5, 6, 7, those are the typical water treatment, surface water body treatment. And out of these 2 also, the major topics where they have been asked. See, from these are 3 topics where plain sedimentation, coagulation, and filtration, around 2 to 3 marks you can expect. Around 2 to 3 marks. So once in a while they will be asking for, if they ask plain sedimentation, they will be going for filtration or coagulation. But every year, damn sure you get a question from the quality of water. So this one chapter is equivalent to the other 3 to 4 chapters. Okay. And then disinfection, that's also included. Whereas miscellaneous treatments, the miscellaneous treatments comes under, if the water consists of too much amount of hardness, we go for softening technique. If the water consists of too much amount of the unwanted dissolved gases, and if it consists of color, odor, and different odor, foul smell, then you go for aeration techniques. And if the water consists of more amount of ion salts, manganese salts, then also we go for aeration techniques. If the water consists of more minerals, demineralization, more fluoride, defluoridation, more salt, desalination, those all comes under miscellaneous treatments. And then finally you are going to distribute the water. These are petty topics regarding to the GATE examination. Mind you, that doesn't mean that you should not prepare. You have to prepare, but primarily you focus more in the water supply engineering. Out of the 9 chapters, your prime focus should be in chapter 3, 4, 5, 6. Quality of water, plain sedimentation, coagulation, and filtration. These are must and should reading chapters. Okay, one must has to read if you want to get very good marks from the environmental engineering. And I say out of this also quality of water is very important. Okay, so this is about water supply engineering. And next, if you see the wastewater engineering, so in the case of the wastewater engineering, again there are a lot of topics. So first one, introduction to sewage, which is a dry weather flow and wet weather flow. What are the different type of the wastewater that we produce from the community? So industrial and storm wastewater, and how we are going to collect that and how we are going to dispose them. That is introduction. Next, and design of sewers. Introduction to sewage and design of sewers. That is chapter number 1 and 2. I am combining saying that. Introduction to sewage and design of sewers. That is the basic thing that you need to know what is the sewage, how you are going to calculate the dry weather flow, how you are going to calculate the wet weather flow, what are the various factors affecting those things, and how once we know how much amount of wastewater is generating, it is said that how much amount of water you send. Suppose 100 ml of water you send to the community, in that 80% of the water will become as a wastewater. So 100 ml you send, 80 ml will comes as a wastewater. Apart from that, this is the wastewater generated by us, and apart from that, by means of natural means, rainwater. After rainwater, that storm water waste would be there, runoff water. So that also we need to find it out. And then we have to check characteristics of sewage. Characteristics of sewage. Okay, so again, you should not dispose the sewage directly into the river water bodies. Why, sir? In the sewage, there is a wastewater. Wastewater matlab in our homes, after we eating, the plates will be cleaned with the water. And along with that water, whatever the food particles, leftover rice particles, curry particles, fruit particles, they will be present in the water, in the sink, kitchen basin. And when we go for fecal, means our fecal matter, our excreta matter. So when we pass as a stools, that also consists of a huge amount of organic matter, right? So majority of the wastewater that we generate in the domestic matlab in the city zones, not from the industries, consists of organic matter. And one has to treat that organic matter before disposing into the river water bodies. Otherwise, what happens, sir? Suppose whatever the wastewater that is generated in the community, if you dispose that wastewater directly into the river, what happens? This wastewater will be having organic matter. When you dump it, river has a high amount of dissolved oxygen and certain type of aerobic and anaerobic bacteria would be there. So this organic matter is going to be a food for the bacteria, and already in the river water sufficient quantity of oxygen is there. So immediately the bacteria eats the food under the presence of oxygen, aerobic decomposition, under the absence of oxygen, anaerobic decomposition. So in the river water, it undergoes a huge amount of the decomposition. When decomposition occurs, the water will get highly polluted. And that polluted water again you have to treat before supply to the community. That is going to be very difficult. So we have to treat the sewage. Our main aim is to remove the organic matter, and that we are going to discuss in the characteristics of sewage, and that topic is BOD. So biochemical oxygen demand, very important parameter. Again, just like in the water engineering, in the wastewater engineering, the most important topic is characteristics of sewage. Again, you can expect minimum of 2 to 3 marks. 2 to 3 marks. You see, in water supply engineering, quality of water. In wastewater engineering, characteristics of the sewage. This is very important. Once we studied various characteristics like BOD, COD, TOD. BOD, biochemical oxygen demand. COD, chemical oxygen demand. TOD, total oxygen demand. THOD, theoretical oxygen demand. Then we entered into the treatment. So treatment of sewage, and in the treatment of sewage, we are going to do various stages of the treatment. First, preliminary treatment. Our aim is to remove the organic matter BOD. But for that, you have to remove something that interferes with the BOD removal. That is a pre-treatment. And then you send it to the plain clarifiers or plain sedimentation. That comes under as a total preliminary, means a primary treatment. So, and then we are going to discuss about the secondary treatment. That secondary treatment consists of activated sludge process, famously known as ASP, and trickling filters. Trickling filter. These two, they comes under as a aerobic process. These are both comes under as a aerobic secondary decomposition, secondary treatment process. Okay, and then we are going to discuss about the oxidation ponds, next septic tanks. This septic tanks is also not for the gate. This is only for the ESE, not for the gate. So it was excluded. Septic tanks is excluded from the gate topic. So there is no septic tanks for the gate. Only for ESE septic tanks is there. And also once we treated this, whatever the sludge that is going to be present at the bottom, you have to treat that also. Sludge treatment. So once we are done with the sludge treatment, then we are going to disposal of sewage effluent. Disposal of sewage effluent. Again, the major amount of the questions will be from in the wastewater engineering is characteristics of sewage, 2 to 3 marks. After that, the weightage is for the activated sludge process. Again, you can expect as 2 marks. Trickling filters, oxidation ponds, there are a very limited number of questions has been asked. In trickling filter, only one time, that two marks questions has been appeared. In treatment of sewage also, only 2 or 3 times 2 marks question appeared in the entire gate. Only 2 or 3 times. So then forget about the septic tanks and the sludge treatment. The only time they have asked a 2 marks question is in gate 2023, man. In gate 2023, they have deviated a little bit. Whatever the examination that has happened in the recent gate examination, in gate 2023, we got 2 marks question from sludge treatment. We got 2 marks question from the disposal of the sewage effluent also. But they are chote topics, they are not big topics, don't worry. Very small, or the concept is very less. The conceptual questions will be appeared more from the characteristics of the sewage. So primarily, you focus in wastewater engineering for the characteristics of sewage and activated sludge process. These are the 2 topics. Apart from this, in the recent times, when we see that too majorly after GATE 2020, so the examiners are giving a more focusing towards the solid waste management and air pollution. From GATE 2020 onwards, every year minimum of 2 marks is coming from the solid waste management, and minimum 2 marks questions is coming from the air pollution. These 2 topics itself, they are going to be covered 4 to 6 marks. These 2 topics, they themselves are going to be covered 4 to 6 marks. So you don't neglect the topics. See, overall, in water supply engineering, 9 topics. In wastewater engineering, 9 topics. Apart from this, so 18. Apart from this, solid waste management, 19. Air pollution, 20. Total 20 topics we are going to deal in with respect to the GATE examination. But out of those, you don't need to study the 20 topics to get very good GATE marks. You need to go the exposure of the entire subjects, but the examiner tries to focus more on the topics like in solid waste management. You should not leave these 2 topics. And solid waste management is a very small topic. So that will not take much time also for your preparation. And air pollution, that's also, air pollution is a little bit bigger topic. So these are two topics. Hardly they will take one day, man. Hardly they both take one day for you to read. 1 hour or 2 days, let's say also. So 4 to 6 marks definitely you are going to get from these two topics. Even in GATE 2023 also, from solid waste management, in one paper 3 marks obtained, other paper 2 marks. In air pollution, one paper 3 marks and other paper 3 marks. GATE 2023, the weightage, air pollution 3 marks, set 1, set 2. Solid waste management, set 1 3 marks, set 2 2 marks. So never skip these two topics. Now, coming to the water supply engineering, don't skip the quality of water. So where 2 to 3 marks. And wastewater engineering, characteristics of sewage, 2 to 3 marks. I primarily focus out of the 20 topics, 4 topics. Water supply engineering, quality of water, wastewater engineering, characteristics of sewage, solid waste management, and air pollution. From this topic itself, I said minimum to minimum of 8 marks you are going to see. You take any paper, you are going to see 8 marks from these 4 topics, minimum. And it can go maximum of 12 marks. Minimum to minimum of 8 marks to the maximum of 12 marks. That is the weightage of 4 topics in environmental engineering. Remaining are, as I already mentioned you, from the treatment of the water supply engineering, you can expect 2 to 3 marks. And the other topics, activated sludge process, sludge treatment, disposal, there you can expect 2 to 3 marks. That itself, it is covering the total 12 to 14 marks. 8 marks of minimum from 4 chapters, remaining water supply treatment 2 marks, wastewater treatment 2 marks. So 12 marks minimum, maximum towards the 14 marks. So I hope you understood what are the weightage for all the subjects. Okay, and now, so once we know what are the various topics, how to prepare for the environmental engineering. Number 1, to be make sure, environmental engineering is not at all a subject where you need to remember tons and tons of formulae. In environmental engineering, you don't require much knowledge regarding to the formulas. It's all about conversions. Units are very, very, very important. So units are very, very important. In environmental engineering, don't focus more on the remembering the formulae. Do focus more on what are the units that are present in the formulae. If you forget about the units, then you will be out of coverage area. Point number 1 to be noted. Number 2, in environmental engineering, 60% of the questions that will be coming as a numerical questions. 40% that comes as a theoretical questions. So this is not solely a subject where you get majority of the numericals. It has both the numericals and theoretical questions. And those theoretical questions are also not a direct question. They are applied conceptual questions are there. So focus more on the units. Unit conversions are very, very, very important. How you are going to convert the units, especially in chapter number 3. In chapter number 3. So where there is a quality of water. In the quality of water also. Now let's explore the topics. So what are the topics that can be covered mostly in the quality of water? In quality of water, majority of the questions so far asked, I'm not saying 100% of the questions, majority of the questions so far they have asked is from the chemical quality parameters. In the chemical quality parameters also, they have asked questions from pH, alkalinity, and hardness. pH, alkalinity, and hardness. And you know, there is an interrelation between the total alkalinity and total hardness. If you know one, obviously you will be knowing hardness. You know the meaning of pH. pH is nothing but potential of H plus ions. You are going to measure the hydrogen plus ions in the water. So that represents the pH. So, and how to find out the pH and H plus concentration? So the H plus concentration is nothing but 10 to the power of minus pH. This is a small logic. whatever the pH they give to you, how to find out the ions concentration. And OH minus, that is going to be 10 to the power of minus POH, whereas pH plus POH is equals to 14, right? So in the case of the pH, it's not about the formulae, it's about the conversions. Generally, whatever the solution that we represent, solution consists of a solute plus solvent, right? So if I discuss about only solid, that should be in terms of mg or gram or kg representation. If I discuss about only liquid, that should be in ml or liters. But I am dealing with a certain matter, solid matter in the liquid. So here you don't say mg or you don't say ml, you have to say mg per liter. That we can also say it as a parts per million. So here the most important conversions that we require is mg per liter to mole per liter. How can you find out the mg per liter to mole per liter? Whatever the H plus concentration from pH you get as a mole per liter. That you need to find out, then you need to convert into mg per liter. So our mg per liter to the equivalent per liter or milli equivalent per liter. These conversions are very important. So for this you need to know what is mole. Mole is nothing but weight of any substance in terms of molecular weight, weight by molecular weight. And equivalent is also known as a gram equivalent, where you are going to see 1 gram equivalent is nothing but weight of the substance with respect to the equivalent weight of that substance. So you need to be careful about these conversions. How to find out these conversions? If I give you mole per liter, 1 mole, its weight is nothing but molecular weight. Yes? If I give you 1 mole, what is the weight? Mole into its molecular weight. That comes as a gram, but I want in terms of mg. So gram converts to mg, then it is going to be mole into molecular weight, gram, 1 gram, 1000. So mole into molecular weight into 1000, that converts mole per liter to mg per liter. Similarly, equivalent per liter, now 1 equivalent is weight in terms of equivalent weight. So if I give 2 equivalents, then what is the weight? 2 into equivalent weight. But again, that comes as a gram. So multiply with 1000. So equivalent per liter into equivalent weight into 1000. These conversions are must and should you require. And once you know these conversions, then you can convert whatever the concentration they give to you, mole per liter to mg per liter to mole per liter, you can do it very easily. Okay, this one point one has to keep in that mind. Next one, in the case of the alkalinity and hardness. Alkalinity in water is due to hydroxyl or caustic, carbonate and bicarbonate, right? Whereas hardness are due to calcium, magnesium and strontium, iron and manganese. But anyways, out of these, the most abundant cations are multivalent cations are calcium and magnesium. In examination, they'll give you ion concentrations of various ions. I'll give you Na+, which is sodium, I'll give you sulfates, SO4 2-, I'll give you chlorides, I'll give you blah 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 blah. Though I give 10 ion concentrations, you need to aware who is really responsible for the characteristic. If I say alkalinity, then the alkalinity is due to whom? Hydroxyl, carbonate and bicarbonate. Out of these also, you are going to consider majorly these two. Why, sir? When the pH of the water is greater than 9, then only OH minus concentration would be there. If the pH of water is less than 9, you simply neglect the caustic alkalinity. We have to take care only these, carbonate and bicarbonate. And in this chapter, around 75% of the questions came from these topics: pH, alkalinity, hardness. Even in GATE 2023, so not GATE 2023, in GATE 2021, so 22, they asked a 2 marks question based on the hardness. And in GATE 2022, they asked a 2 marks question based on the conversions. One of the question they have asked in a previous GATE is, you see, so the question was 100 mg of HNO3 is added to water to 1 liter. To make 1 liter, then what is the value? 100 mg per liter. The concentration of the HNO3 is 1 mg per liter. So what they're asking is pH. What is the pH of water? 100 mg of the HNO3 is added to water to make it as a 1 liter. Then what is the pH of water? So what is the concentration of the HNO3 here? Concentration of HNO3 is nothing but 100 mg in that liter of the solution. 100 mg per liter. But I want whom? pH. So what is the pH? pH is nothing but negative logarithm of H plus concentration. The actual definition is potential of H plus ions, right? But for that, first of all, I need to know the H plus, right? When you add HNO3 to the water, the HNO3 will dissociate. The HNO3 will dissociate. So HNO3 will dissociate to H plus plus NO3 minus. H plus plus NO3 minus. So now this one part will give one part of the H plus. That one part is nothing but 1 mole of H1O3 gives 1 mole of H plus ions. 1 mole of HNO3 means this is 1 molecular weight. This is 14 and this is going to be 3 into 16. So total this comes as 63, right? So 63 parts of HNO3 releases just, what is the H? 1. 1 part of H plus ions, right? 63 parts releases 1 part. Then 1 part of HNO3 gives 1 part of HNO3 gives how much? 1 by 63 parts of H plus ions. 1 part of HNO3 gives 1 by 63. But what is the concentration of HNO3? 100 mg per liter. 1 part, 1 by 63, 100 mg per liter. So H plus ions concentration is how much? 1 part gives 1 by 63, 100 parts. 100 by 63, this is mg per liter. So it's not about only the point. I have to go with the stoichiometry equation. I have to check how many number of moles are required. And finally you get mg per liter. So don't use that mg per liter. If I want to find out this H plus, I have to find this one in terms of mole per liter, right? So once I know this, then how to find out this mg per liter? So anything of x in mg per liter is nothing but x of mole per liter into 1 mole. 1 mole, if you want to write 1 mole in terms of weight, multiply with molecular weight. 1 mole of oxygen, 1 mole of O gives 16. What is 16? Molecular weight, 1 into 16. 2 moles of O, 2 into 16. But that is in terms of gram, you need to convert into mg. So now x mole per liter is nothing but x mg per liter by molecular weight into 1000. So what is the x I have? 100 by 63, 100 by 63. And what is the molecular weight of the H plus? Molecular weight is 1. What is the molecular weight? 1 into 1000. You get this in terms of mole per liter. So see, what I have added is whom? HNO3, but I want pH. So HNO3 is an acid that definitely will induce as H plus ions in the water. So this much will give this much amount of the H plus, that mg per liter. You need to convert that into mole per liter. Once you get the mole per liter, then only you have to write down the pH value. So the point is, the conversions are very, very, very important. And there are certain type of questions that you can expect, as I'll give you the ion concentration. I'll give you the ion concentration where, so I'll give you Na plus, Ca2 plus Mg2 plus SO4 2 minus O Cl minus HCO3 minus K plus CO3 2 minus. I'll give lots and lots of concentrations, ions, and their concentration either I can give mg per liter or equivalent per liter or milli equivalent per liter. I'll give them in terms of those. So after giving all these things, then I'll ask you the alkalinity and hardness. Just because I have given these many things doesn't mean that you should be going all the ions. Hardness is due to multivalent cation. Multi means more than one. Na plus, this is single, eliminate that. Hardness will not cause by means of Na plus. K, that's also cation, but that is single valent, eliminate. The only multivalent cations that produce hardness is Ca2 plus and Mg2 plus. Okay, and hardness is due to whom? Hardness is due to hydroxyl, carbonate, bicarbonate. So there is a bicarbonate, there is a carbonate. Forget about the sulfate and the chloride. So whatever the data they give, out of that what is required for you, you check. Alkalinity के लिए what required? For hardness, what is the requirement? And based on the units, if they give mg per liter, fine. But if they give milli equivalent per liter, you need to convert that. If they give equivalent per liter, you need to convert that. And one more conversion you require over here is, if you want to convert anything in terms of X to Y. I want to convert the alkalinity in terms of CaCO3. How to convert that? So, majority of the questions from the quality of water was based on pH, alkalinity, hardness. That doesn't mean that there is no other type of questions. So, after this one, they are focused, they focus on the MPN table also. So, based on the MPN table, there are some questions. They have given the standard dilutions of 10, 1.1. So, they'll give you the sample tubes. So, that goes from 10, 1.10, 0.01, 0.001. They'll give you the positive test, they'll give you the negative test. This is a sample tube, and they will be give you the standard dilution tables. Standard dilution tables. So based on the standard dilution tables, you are going to get the positive combination. You are going to get more number of questions. So from this one. So these are the topics they cover more in the case of the chapter number 3, the quality of water. I am primarily focusing on the major topics. And now coming to the characteristics of the seaways. In the case of the characteristics of the seaways, they will be asking more number of questions on the BOD. So, in the characteristics of seaways, so they will be asking more number of questions on BOD. So, how to find out the 5-day BOD? How to find out the 5-day BOD? And they'll give you various parameters. How to find out the 5-day BOD? 5-day BOD that at 20 degrees centigrade is nothing but DO initial minus DO final into dilution factor. So from the 5-day BOD, how to find out the ultimate BOD? The ultimate BOD. So 5-day 20 degrees BOD, this can be written as ultimate BOD into 1 minus e to the power of minus k into t, where t is nothing but whatever the time that you wish to go for. Okay, so this is known as a BOD rate constant, and this is nothing but the time. So y at 20 degrees centigrade. Anytime you substitute the k value, and you will be find out the ultimate BOD. So you remember the graphs. If you remember the graph, you know, with respect to time, bacteria utilizes the BOD, means oxygen. This is a BOD, and this is nothing but the organic matter. So with the time, bacteria, whatever the bacteria, either it is aerobic or anaerobic. So initially aerobic bacteria that utilizes the oxygen, right? And there are different type of bacteria, mesophilic, thermophilic, psychrophilic. Okay, so they will eat the organic matter. Organic matter depletes. more the amount of organic matter decomposes, more oxygen is utilizing by the bacteria. So these are the first stage of the decomposition. Based on this, we have derived some expressions. And how to find out the 5-day BOD, and how to find out the ultimate BOD, what is the relative stability, what is the population equivalent. So 4 models: 5-day BOD, ultimate BOD, organic matter present in the water, relative stability. These are the topics majorly they focus on the characteristics of sewage BOD. Apart from the BOD, there is one more thing, COD. COD is a completely experimental procedure. We don't do any mathematical analysis. And in the case of the CHOD is there, so TOD is there. For that we do some mathematical analysis. Based on that, in GATE 2023 there was one question. Okay. So these are 2 topics they cover. In the case of the characteristics of sewage, so don't miss the BOD topic. In characteristics of sewage, BOD is very important. In the case of the quality of water, pH, alkalinity, hardness, and then MPN table. These are important. So focus more on the unit conversions. Focus more on the unit conversions. They are very important. And apart from this, in the case of the solid waste management, in solid waste management, you can get a numerical question. Theoretical topics would be there. Theoretical questions are there. What are the different type of the municipal solid waste, hazardous waste, and industrial waste? And how you are going to dispose the solid waste, either by means of the landfilling, or by means of composting, or open dumping, or incineration, or pyrolysis, or pulverization. But the numerical, if the numerical obtains, in recent GATE 2023 paper also, a numerical comes as, if you burn that solid waste, how much amount of energy it is going to be liberate, the calorific value of the waste. Energy, as it is discarded, how much amount of energy that is going to be liberate. So if you take any waste, if you take any solid waste, if you burn 1 kg of this solid waste, how much amount of energy that is going to be liberated? Energy as discarded is nothing but 100, whatever the components, summation of components of each energy by 100. So in the solid waste, there will be lots and lots of components. Paper will be some percentage. Paper burn, it releases some energy. Charcoal, it burns, it releases some energy. Plastic, so there are different type of forms that each one you find out. So they'll give you the percentage by weight, and they'll mention you the energy that discarded in kilojoules, like kilocalories or kilojoules per kg. Okay, and if you remove the water, which means moisture free, if you go for the moisture free, then the energy is nothing but 100 by 100 minus a percentage of the moisture into energy as discarded. If you go for the ash and moisture free, if you go for the ash and moisture free, this is 100 by 100 minus percentage moisture content minus percentage ash into ET. So from the solid waste management, you get a question, you will be getting the question based on the chemical analysis of the municipal solid waste. And physical analysis is about finding the specific gravity. You can use the Marshall technique. 100 by specific gravity of the municipal solid waste is equals to percentage of that component by the specific gravity of the each component. Okay. And last one is, so about the air pollution. So in the case of the air pollution, they'll be asking numerical questions. They had asked so far numerical questions mainly on the control technologies. In air pollution, at the end, we'll discuss about the preventive measures and control technologies. From the control technologies, they'll be asking questions based on the gravity settling chambers. Majorly, they asked questions on electrostatic precipitators. We have one formula to find out the efficiency of the electrostatic precipitator. They'll be asking how many number of bags required for the fabric filters. Number of bags required for the fabric filters. So there is control methodologies for the suspended particulate matter. We have gravity settling chamber, we have fabric filters, we have electrostatic precipitators, we have cyclone separators. They'll be asking certain questions. So we have already formulated those things. You please go through those. And then combustion. So there will be lots of industrial effluents that will be coming out. Suppose in the case of the industries where there is a oil refineries, where the coal is used as a primary raw product, it liberates the sulfur, right, sulfur dioxide. So generally coal consists of 1 to 4% of the sulfur. Now they'll give you questions, again stoichiometry equations. If an industry using this much amount of the coal, which consists of that much percentage of the sulfur, how much sulfur dioxide will be liberating into the atmosphere? So they will be giving the questions based on the chemical reactions. When you release the sulfur into the atmosphere, sulfur reacts with oxygen and produces sulfur dioxide. Nitrogen reacts with oxygen and produces NO and NO2. So they will be asking the stoichiometry, just like this question. 1 mole gives 1 mole of other thing. 1 mole of sulfur produces 1 mole of sulfur dioxide. So two models of questions that one can expect from the air pollution is, number 1, from the control technologies. Number 2, from the combustion techniques, or when these gaseous pollutants enters into the atmosphere, the stoichiometrical relations. Number 3, based on the lapse rate. As we deal majorly in the troposphere, how the environmental lapse rate, that is environment that depends upon the surrounding temperature, climatic conditions, topographical, that is the environmental lapse rate. And one more lapse rate, adiabatic lapse rate. Irrespective of the surroundings, when you release a hot air sample, the temperature of the hot air sample decreases by 9.8 degrees centigrade for every 1 kilometer. Up to it becomes a condensate, and beyond that it reduces by 6 degrees centigrade for 1 kilometer. That is constant. Based on the adiabatic lapse rate and environmental lapse rate, we have a lot of other type of lapse rate: subadiabatic, superadiabatic, inverse, inverse and neutral. So based on this, we have some behaviors known as plume behaviors. This lapse rate for the numerical, whereas plume behavior, that is for the theoretical questions. In air pollution, you have to study each and out, because possibility of theoretical questions, possibility of the numerical questions, both are same. From the past few years, they are focusing mainly towards the solid waste and air pollution. Don't neglect. Air pollution, you need to know what are the major pollutants, what are the minor pollutants, what are the gases that are responsible for the greenhouse effect, and how to measure the concentration of the gaseous pollutants. If gaseous pollutants are released into the atmosphere, how they are going to be mixed, and how to find out their concentrations, and what are the various plume behaviors, and finally control technologies. So in this session, I have explained you what are the topics that comes and what is the weightage, and where you are going to take more weightage: quality of water, characteristics of sewage, and in quality of water, what are the different type of questions from models they can ask, and in the case of the characteristics of sewage, where they can ask more number of questions, and in the case of the solid waste management, again chemical analysis. In air pollution, total. So I hope in this session I gave you eminent knowledge for you to look into the environmental engineering. So now you got to know where you need to give more importance. Again, a star mark, that doesn't mean that you should not read the other topics. You have to read the other topics such that you get more coverage, more understanding towards the environmental engineering. So hope this session was really helpful for you. So that's all from my side, and that's the end of our session.